Mercury and lead are the two heavy metals that we are going to talk about in this section. Now, the first thing that I want to do is talk a little bit about heavy metals and what they are. You may or may not already be familiar with this term, heavy metals. Usually I think of things like cadmium and, of course, lead and so on. But it turns out that there's a lot of metals that are heavy or considered heavy by this category that aren't necessarily heavy. So these are usually based on density or an atomic number or on atomic weight. And so for the elements that we know have a pretty high atomic weight or atomic number, like uranium, and density, again, like uranium, we're not really surprised that these are categorized as heavy metals. But the truth is that even elements like iron and copper are included in the heavy metals list. If you look at the periodic table, you should be familiar with the fact that only some of these yellow elements over here on the right-hand side are the nonmetals, and everything else is considered a metal or a semi-metal. And all of your elements here in the first two groups and then in the D block and the F block, these are all metals. So only the little elements, and hydrogen is not a metal, so like lithium, beryllium, sodium, magnesium, up to about titanium, these ones are the lighter metals. And then after that, basically everything is a heavy metal. So, I mean, all the metals are heavy metals. So you've got a pretty comprehensive list of heavy metals, but a lot of the metals are not considered to be significantly toxic. I mean, iron, for example, we handle all the time. Part of the reason that we don't have too many troubles with it, of course, is that it doesn't dissolve super well. But even small concentrations of iron, these are important for us, right? We use iron as an oxygen and carbon dioxide transport in our blood. So iron is a micronutrient for us. So many elements are micronutrients in our bodies. And so we not only can, but we should absorb a certain amount of them in order to stay healthy and to stay alive. But some of our other elements, like mercury, are not essential elements in our bodies. And so anything other than a very, very small amount of it is usually problematic to us. So getting back to mercury, the interesting thing that I find about mercury is that lots and lots of people are really super paranoid about it, probably more paranoid than some things that I think we should rightly be more paranoid about. And I'm not going to minimize the fact that some forms of mercury are extremely problematic. But the interesting thing is that if you look at mercury in its metallic form, which is the liquid, this is totally inert. You can drink it and it would give you a stomach ache just because there's a lump of liquid that's sitting in your stomach. Now, please don't do that. But it is an inert liquid. It has metallic characteristics, which makes it really interesting because there aren't very many liquid metals. In fact, this is more or less one of the only ones. And then it has multiple different ionized forms. So the +1 form comes in two different iterations. It can either come as a dimer or as a single one. And these form mostly, or I should say, fairly insoluble salts. And they are not very toxic. So if you encounter mercury chloride or something like that, number one, it probably won't dissolve, so it'll be like a rock in your environment. But it's also not hugely toxic. Now, I wouldn't recommend licking it, but still. You also have Hg2+, and this is not toxic. But the problem is that it easily transforms and it can be methylated. And then it's the methyl mercury that's really the problematic one. So if we have methyl mercury, so a mercury Hg2+, that picks up this CH3 group, This is extremely toxic. And so it can be, the problem is that if you have an inert liquid, well, what does it take to get you to the Hg2 plus and then to the methylated form? So people mostly just don't take the chance. On the other hand, this can also be inactivated by turning it into dimethyl mercury, which is non-toxic. So mercury used to be used a lot. People used it in thermometers because it's got a really great linear expansion ratio. As you increase the temperature of the mercury, it takes up more space. And this is how liquid-based thermometers are made. And it had a really super linear range, which ethanol, which is the replacement, does not really have. So it's not great. But anyway, people mostly don't use mercury thermometers anymore. And now most mercury is present from mining debris and from coal and oil burning. So it's present as a trace component in rocks that get mined up, including coal and oil. So, for example, cinnabar, which is a really pretty reddish rock. This is used in several industries, and it's a serious area of exposure for mining. But coal mining also exposes people to mercury. And in fact, coal power plants, they produce aerosolized mercury. Oh, and I forgot to add here that mercury vapor is toxic and is highly problematic for the body. So even though that's the neutral form. So you can have mercury vapor being produced by these power plants as well. So if you encounter, or if you are living near a coal or oil plant, or if you are near where there was a spill of some kind, then you could be exposed to mercury in your environment. Now, most people have heard about mercury as a problem in fish. People will talk about don't eat too much tuna or halibut or whatever. Yes, this is a problem because the larger predator species, it's not that they, sequester it on purpose, but the larger predator species eat the smaller fish that have a little bit of contaminated meat. And then it binds, it stays in their body. And so what am I trying to say? I'm trying to say that it accumulates. So predators, which includes us, because we are fairly long-lived creatures, and when we get exposed to pollutants, they can build up in our body. This is when we end up having potential problems. So if you are absorbing mercury in its ionized form or in its methylated form, which is also ionized, then what we're going to hope is that we end up having that mercury react with something like sulfur in our bodies, which mostly deactivates it. It makes a pretty strong bond. And this also happens with antimony. It will bind mercury with antimony. And it will deactivate that mercury, so it'll bind very strongly with it. But mercury vapor used to be associated with hat making in England, which is why in Alice in Wonderland they used mercury vapor to stabilize the felt for the hats. This is why you have the Mad Hatter. And this brings us to the physiological effects, which is that the toxic poisoning affects the central nervous system. So you get irritability, you get loss of cognitive function, you get depression, you get lots of different nasty central nervous system effects from mercury. And this illness or this ailment is called erethism. And it's usually due to industrial exposure. Now, when we talk about industry, I think I said in the previous video that the EPA came into being in 1970, and so this has not been regulated until very recently. So I'm going to say historically, it hasn't been regulated very much. And so that means that there are lots of dump sites. Whether people did it on purpose, you have mine tailings, you have places where they just took a bunch of waste and they just dumped it, right? And some of these, at least in the US, we call these Superfund. And so this Superfund is a cleanup fund that's looking at remediation of various dump sites for a wide range of different industrial waste. So most industrial mercury is now regulated in the US. I don't know about other countries. Except not in coal burning. So this is good that most of our industrial mercury is regulated. We can look at this as a success story. We've significantly decreased the ability of most industries to be able to dump their waste without repercussions and without treatment and without, oversight. But this is the one area, or one of the areas that we really do need to make sure do get regulated so that the emissions, not just carbon dioxide, right, but sulfur and nitrogen and mercury and lead, and in fact there's radioactive components of coal as well. These all need to get cleaned up as well, and also regulated so that way people can't just keep burning stuff with no oversight. Okay, so that's sort of our quick overview on mercury. Lead is our other one. This is kind of a hot topic right now. We had a recent problem in Flint, Michigan. And you probably are already aware of this as an issue. The Flint, Michigan water crisis is now a few years old, and it's still not totally resolved. This is an NPR article that looks at it. It's from 4 years ago. And the focus is on lead, but there were actually other contaminants in this water as well. So when we look at the lead part, what we're really paying attention to are the blood lead levels. And these have been measured for children and for adults, both before and after this particular crisis. Now, I don't know how much you know about Michigan, but Michigan has had a lot of industrial manufacturing. Is one of the locations where there used to be a lot of car manufacturing. And so there's been quite a few heavy metal contaminants in this environment, not just limited to lead. But let's get back to talking about blood lead levels. And when we're paying attention to lead levels, we're looking at how much we are observing actually in lead or in the blood, because elevated levels are again associated with central nervous system problems. And this is especially true for children. So our levels for adults, we want to have less than 10 micrograms of lead per 100 milliliters of blood. Now, that doesn't mean that they take 100 milliliters of your blood, but obviously this is just a concentration level. And another thing that you will notice is that 100 milliliters gets often labeled as a deciliter, which is not a unit that we use very often, but this does tend to be a pretty common one that we see. And so you'll see like the blood level was 2.6 micrograms per deciliter or something like that. So if you are curious, this is the same thing. And when we are looking at adults, what we want is less than 10 micrograms per milliliter. And most of us have levels that are quite a bit lower than this. We've put a lot of work in the United States on decreasing environmental lead. And we'll talk a little bit more about some of the use or some of the causes of blood lead levels and where the lead comes from or used to come from in just a second. So if you get as high as like 40 micrograms per 100 milliliters, then you start to see behavioral and cognitive effects. Measurable changes. Once you get up higher than that, then you get some really serious medical effects. This is sort of summarized as peripheral neuropathy. I had to look this one up. It means that your cell signals are not, your nerve signals are not sending messages very well, so you can get phantom pain. You can have lack of response in different areas. So that's pretty serious. And then if you get quite a bit higher than that, this is when you start just seeing like death and stuff. So we will not go that far, right? We want to keep our blood lead levels much lower if at all possible. So when people would encounter lead, our main sources of lead were from lead-based paints because there's a lot of pigments that use lead and other heavy metals. And we also used to have leaded gasoline, which we've talked about a little bit. And both of these have been discontinued in developed places anyway. So most of the older houses will still have lead-based paints, but usually they're covered with newer paints that do not have lead. I'm sure mine does. I haven't looked. My house was built in 1947. So I'm sure there's some lead-based paints, but we just cover it over with something else. And as long as it stays sequestered, then it's not really a problem. It's when you get lead dust or chips of lead paint off the ground that can potentially be inhaled or consumed by children. This is when you start getting paint as a source of environmental lead. Leaded gasoline, this used to have something called tetraethyl lead. And it was an anti-knocking agent, so it made the fuel burn more smoothly. But it also produced a lot of lead that then got into the atmosphere, which then drifted down and settled in our soils and all kinds of places. So we still need to monitor lead in soil, especially by major roads, to look at what the lead content is of these, because it can be absorbed by the plants. So the great news is that even with our problems of the Flint elevated lead levels in the water and therefore elevated blood lead levels, very few of the children registered higher than 5 micrograms per deciliter, which is the threshold for children. I guess I should add that to our list here. So for children, the EPA action level is 5 micrograms per 100 milliliters of blood. And most of the children in the Flint, Michigan area had been seeing decreasing blood levels of lead in that area for the past, 20 years or so. And luckily, even with the recent increase in the lead, most of them, the blood lead levels still stayed below 5 micrograms. But the problem is that there's no safe level. So even though this is the action level, it doesn't mean it's actually good for you to have any kind of lead inside your body. So hopefully, even though these were very quick introductions to mercury and lead as contaminants, I want you to view these as positive interventions that we've done, because we have regulations now that limit mercury and lead exposure. And so even though lead mostly is 2+ and it's fairly soluble, well, it just depends. Anyway, so even though we have soluble cation forms of both mercury and lead, we've instituted great regulations with the EPA that have improved environmental health and public health from exposure from these heavy metals. So this is one of the good news that we have, and we want to keep it that way. We want to make sure that we keep pressure on so that polluters do not, or not allowed to produce waste that then is going to damage our environment and damage our health. So I hope you've enjoyed learning about a few of these pesticides and other pollutants. And we'll continue talking about more water-soluble and insoluble compounds as we go into next week.